Hello everyone. In this video I'm going to look at solving solving trigonometric equations. In this one I'm going to be looking at how to isolate the trig function itself. So my question is to solve 3 tangent squared of theta minus 1 equals 0. And I need to specify by saying over the interval from 0 to 2 pi. So from 0 to 2 pi is where we're going to define theta. What that means is I need to consider specifically for one revolution where my answers are going to be, and I also need to isolate my tangent function before I solve this equation, before I identify a radian measure that will work. So what I need to do is, first of all, I will isolate my tangent function. And I treat this just as if it were 3x squared minus 1 equals 0. I would isolate x by adding 1. 3x squared equals 1. Then I divide each side by 3. So x squared equals 1/3. And then I would take the square root of each side. I'll do the same thing now with my tangent squared. And I'll treat tangent just like a variable. So 3 tangent squared of theta minus 1 equals 0. I'll do the same thing. I will add 1 to both sides. So now 3 tangent squared of theta equals 1. Next I'll divide each side by 3. Now I have tangent squared theta equals 1/3, and I'll take the square root of each side. So now I have this. I will have tangent of theta is equal to, now normally I have the square root of 1/3, but I can break that down into the square root of 1 over the square root of 3, which I'll make 1 over the square root of 3. And because I'm taking the square root of each side, I'll put plus minus. So what this means is I'm looking for a value for theta that gives me both the positive and negative result of 1 over square root of 3. So we have to consider, when we look at quadrants, because we're dealing with trig functions, where is tangent both positive and negative? Well, that's going to be every quadrant. So we're looking for a solution to this that's present in all 4 of my quadrants. Again, because of the plus and minus, we're saying where is tangent both positive and negative. So we need to consult either our 30-60-90 or our 45-45 right. And in fact, it benefits me a little in this case to not rationalize 1 over the square root of 3, because it'll be easier to figure out from my triangles that since in my 30-60-90 I have a square root of 3, it's easier to identify that that is the triangle that I'll be using. Since I'm talking about tangent, what angle could I take opposite over adjacent to find 1 over square root of 3? And in this case, you can see it's going to be my 30 degrees, or pi over 6. Now since I'm talking about pi over 6 in each quadrant, of course I have pi over 6 here. Using pi over 6 as a reference angle, I'll find the remaining angles in each quadrant. And what they'll be is I'll have 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now since I'm talking about one revolution, within one revolution, what are my solutions? I don't need to put plus pi k, because I'm not being asked for all solutions. That's a different kind of question. So these four angle measures, these four radians are my total solution. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 are my answers. So again, I want to solve my original equation as if it were the tangent squared were a variable. Take note of what quadrants this implies, and then find the appropriate angle for each one.